Getting started today is just going to be a review lecture. So we're just going to be reviewing stuff and having some clicker questions, assuming, of course, that this is now available for me to ask the questions. We'll have to see on that. So the test, some people have asked because previous tests had been over different chapters, but the tests last year and this year is just over chapters 1 through 3. So people who are getting worried, they're thinking, what? Previous tests were over 1 through 4 or 1 through 5. This year's test is just over 1 through 3. I looked at the homework scores. I updated the homework scores to the latest this morning. And some people are having a hard time with homework. If you're having a hard time, please, come to my office hours. I have that Google Hangout I'm doing so people at Southwestern can also, ask me questions during office hours. Or you can email me a question, contact me so we can make sure you get the understanding and then, of course, get the high grades in homework. Homework is what, 10%, something like that if your grade. It does make a difference, but the goal of homework is not for grade. It's to help you understand material better. So if you have a problem, please contact me, let me know so we can work on improving people's scores in homework who are not getting the high grades. Okay, moving forward, Chapter 1. Chapter 1 was an introduction, and so it introduced things like quantities and units and uncertainties. And so the first thing here for Chapter 1 is make sure you know the prefixes. I don't think that there are any specific questions on the exam that are asking you about the prefixes, but you should have memorized from femto, which is 10 to the minus 15, up to peta, which is 10 to the plus 15. So just memorize that list of prefixes, right? Femto, what comes next? Pico, then nano, micro, milli. Everybody knows centi. It's not an order, or 3 orders of magnitude difference. And nobody's going to worry about deci or deca or hecto. So then the next one we have to learn is kilo, mega, giga, tera, and peta. So make sure you know those and know what 10 raised to what power each one is. Also make sure you know what the base units are that we use in science. In science we use the metric system, so our base units, everything we're going to be doing this semester, well, virtually everything for a long time is only going to have the 3 that I listed here. Kilogram for mass, remember it's kilogram, not gram for the base unit. Meters for distance, and seconds for time. Make sure you remember how to convert units. My son was asking me questions last night from his high school chemistry class on conversion of units. And it's important to remember the conversion factor always has to have a value of 1. So you have equivalences like 1 inch is equal to 2.54 centimeters. Now, in case you don't know, that's actually an exact conversion. The inch and the centimeter are tied together with that exact relationship, so there's infinite significant digits here. So if I ask you how many meters long is 12 inches, you'd say, well, 12 inches, and then I need to multiply it by a conversion factor that is equal to 1. So with that relationship, I can say, I need to cancel the inches, so I'm going to put the 1 inch on bottom, 2.54 centimeters on top, and now I will have my inches cancel, and I'd have 12 times 2.54, which I did not do the calculation. Yeah.
Do you have a preference that we actually add the 1 down as opposed to just saying IN or something like that?
You could put 2.54 cm/IN. That's fine. Yeah, I don't have a preference there except for I want you to do it correctly.
Okay.
Jordan has a question.
So say there was more significant figures than 12 inches there. Say you had 4 significant figures, so it's 12.00.
Yeah.
And you multiply by 2.54.
Yes.
Would you mark as points off for only counting 3 significant figures, or would be? Okay. I'm going to repeat the question so the people at Southwestern can hear it. The question is, if I had given a number instead of 12 inches, if it had been 12.00 inches,
and then I use the 2.54 centimeters over 1 inch, or I'll write it the way that, maybe I'll write the way. I forgot, different program. I was using the other one to do your test solution just before class. So the way Colton was saying, there's my conversion factor. It means exactly the same thing. It's just written a little differently. And so the question Jordan asked was, if you put your answer here with only 3 significant digits, would I mark off, right? And the answer is yes, that has 4 significant digits because the 2.54 is an exact number. And so yes, I would. Jordan has a follow-up question.
So when you give us a conversion factor of, say, the 1 inch equals 2.54 centimeters, would you note that this has infinite?
I actually usually give you way more digits than you'll use because very rarely are they exact like this. I haven't in the past, but I will think about how I can note that, because the question is, would I tell you the conversion factor is exact or not? And really, it'd be to your benefit to know, so I'll try to figure out a way to do that. There were at least 2 more questions. Gila and Paris?
Will you give us the more obscure conversion factors in the equation?
I will give you whatever conversion factors you need. Paris question.
My question.
Okay, Paris and Gila both. Will I give you more obscure conversion factors? I'll give you whatever ones you need. And if during the test you think you need one that I didn't give you, just raise your hand. I will try to make sure, I'll either say you have the conversion factor you need, or even if you don't need it, I might just come up to the board and write the conversion factor so everybody has whatever you asked for. Anybody over there at Southwestern have questions on this? Gonna go with that's a no, since there's no hand and no voice. Okay, let's do a couple clicker questions here. They're not overly sophisticated, just wants to make sure that we remember these things. What is the base SI unit for time? And if you answered before I started reading, just to be safe, answer again, because when I got it started, there were people already started answering. Now, this is not a tough question. It's not a tricky question, just to make sure we're following along. All right. Give you about another 5 seconds here. What?
It's not letting me log in.
You're okay.
Thank you.
Okay, so moving on now. We had one person that said hour and 53 that said second. And that's good. The second is the standard unit of time we use in science. So next question, what is the base unit for distance? And you can answer starting now. Okay, wow, that's the biggest response we've had to any question. I know Manawa is back there. I saw him. Don't have an answer yet. I'll give 5 more seconds here. Okay, this time it was 1,353. Once again, we had a very strong convergence on meter. I can see why somebody might have said kilometer because, of course, the one coming up is going to be kilograms. You all know the answer to the next one. I won't waste our time asking it. Well, no, I will. Just to point out some interesting things. Did anybody notice that one answer was on both of the last question and this question? The parsec. Because it has that sec there, people like to think that it has time. But it's actually a parallax arc second. That's a second of arc, because when you measure degrees are broken up into 60 minutes per degree, and a minute of angle is broken up into 60 seconds. And so that's the parallax second. Light year, some people also get confused. A light year is the distance light travels in 1 year. So it's a distance, not a time. All right, and the next one is, and once again, I got to change the slide so you can't answer yet. Now you can answer. What is the SI base unit for mass? There we go. Madewell's got his answer. Okay. We are up to 59 responses. Do I have 60? All right. We had, this time, not quite as strong of an agreement, which is actually a little confusing because not less than a minute ago I said the answer on the next slide is kilogram. But it's kilograms, not grams. A gram is indeed a unit of mass. A slug is also a unit of mass. The slug is the imperial system's unit of mass. So if you're using pounds to measure force, slug is the unit of mass that goes with that system. So a pound is what? A slug foot per second squared, I think. Carats, I don't know. You had a homework problem that defined what a carat was, new to me. It was you that had that problem, right? Not my son, because no, it was him. Okay. Well, we did a conversion between carats and ounces. The Newton. Why is the Newton wrong? It's a force, not a mass. Force and mass are not the same thing. And so I put that one on there because it's a common misconception. Now, we had 1 out of 59 that answered that, so it's not very common among you. Well, because you've been learning a little about physics. All right, going on with chapter 1, we had discussion, we had a lab that focused on accuracy, precision, and significant figures. Now on the test, there will be one question that's specifically about doing significant figures. Just finished doing the solution to that before class. I got through all of 2 questions before coming to class. I did not start early enough to get very far. So make sure you know the rules for significant figures. And rather than reiterate the rules right now, I'm going to ask you a clicker question on those rules. So you could answer now. I have this number, 539.35 divided by 600. You have no additional information besides what that is. The number is what the calculator tells you. Select all of the answers that could be correct based on the information that was given, and then press enter to submit your answers. So this one is ambiguous. There's more than one possible answer. Select all of them that you see. Okay, I'll just give it another 5 seconds. All right, this time around our answers are much more spread out. Of course, there was more than one to answer to begin with. Okay, now, if I hadn't already spent more than a quarter of the class period and we're at through the first chapter, which is the shortest one, I would now have you discuss with your friends. Instead, I'm going to have you blurt out to the classroom. We had the largest group of people said 3. What is a good reason for answering 3 significant digits?
Largest group said 5.
The what?
Largest group said 5.
Yeah, 5 is the
Oh, the largest group said 5? Oh, you're right, 5. Well, I didn't see that one, so let's stick with 3. What's a good answer for answering 3?
600 could be exact, but it isn't denoted by a decimal point. It could, without units though. I don't know. I thought maybe it was just a very open-ended question on that.
Okay. Well, I'm going to try to paraphrase what he said, make sure it's correct. Because the 600 could be 3 significant digits. And when you're multiplying and dividing, the lowest of the number of significant digits is the number of significant digits in your answer. So that's a reason why C could be correct. Now I'm going to actually make sure this question is answered by people at Southwestern, just to want to make sure that they're part of this here. So since I was wrong and 5 was the answer that had the most, what's a good reason for 5 to be the correct answer?
600 is the exact number.
Okay, if 600 is an exact number,
Therefore, 539.35 would be the limiting factor.
okay, there's a great answer right there. If 600 is exact, it's an infinite number of digits, but the 539.35 has 5 digits. So then it makes sense 5 would be a correct answer. So these two definitely very defendable. Going down, I am pretty sure 29 is the next smaller one. What would be a reason to have only one significant digit as a correct answer?
600 could just be a 6.
Okay, 600 could just be a 6. It could just be 1. So that makes sense. Only 10 people said 2. Anyone want to defend 2?
Oh, I mean, it could be 60. It's not specified.
Colton says it could be that the 600 is good to 2 decimal points. It's not specified, it's ambiguous, and that's correct. So all of those could be correct. 4 could not be correct. It can't be correct because that 600, if it has more than 3, it has infinite. 6 can't be correct because, well, if for some reason the 539.35 was exact, you would never assume it's exact. But if it was exact and the 600 was exact, well, that couldn't be it. Likewise, that couldn't be it. So we have 3 answers it couldn't be. Infinite is highly unlikely. You would have to be told something to assume that 539.35 is exact. But if it was exact, then infinite would have worked. Do you have a question, Jonathan?
Well, yeah, I was going to say, because like we said, with the conversion factor for centimeters to inches, like 2.54. So by the same logic, since there's no more information, it could be anything else that's on the question.
Right. And that's what, when in writing questions, on the test question, if it's got a decimal, assume that it is good to the decimal places and that it's not randomly exact, okay? I don't want people to say, well, I'm just going to assume every number given to me is exact and it has infinite digits. The question, Colton.
Given a situation like this, though, wouldn't you just take that ambiguity and go with the least number of sig figs?
Well, if they're both exact.
Well, I mean, like they said, without knowing that they're exact.
Yeah,
there's nothing to imply they are.
The standard way that I would interpret this, if it was on the test, would be to assume the best of the ambiguous one and say it's 3, and then assume the one with the fraction is, that many digits. The guy in the front row there, I don't know your name, but it looked like you had a comment. We want that's at Southwestern. Well, even if he did, I guess they're not going to turn the sound on, so he won't be able to ask whatever his question was. Okay, so moving to the next one. This is a question with addition, and you can answer starting now. How many significant digits are in the sum? And here's 2 numbers added. Now I changed that to 601, and let's just go ahead and make the assumption right now that it's, well, no, I'll leave it to you. let's at least make the assumption that this here is not exact. Okay, I'll give it about 5 more seconds. And closing it. So we had,
Hey, I don't think we can hear you. The sound cut out.
the sound cut out. Oh darn. It looks like the broadcast thing down
There it goes
below.
back.
Yeah, but the broadcast thing's out. Can you go upstairs and see if you can get some AA batteries?
No, it's gone again.
Where would it be?
From our division secretary. I swear I checked those. No, I changed the battery since then. Yes. Okay. This is kind of rough because what are they going to know that I'm talking about? Let me see if I can.
Write them a message.
Yeah, no, I'm going to. That gives me horrible feedback. Yeah, hey, how you doing, man? Okay. Plan B. What?
He waited.
Yeah, that's why I wave back. See? Yeah. Okay, I turned off my sound so I can't hear you, but now you can hear me at least through the tablet, so you have some sound. You guys can hear me now, right? Give me a thumbs up or something. Okay, excellent. So back to the presentation until we get those batteries replaced. I must not have. What was it?
The question.
Back to this?
Yeah.
Okay, yes, you're right. I was in the middle of it. Got sidetracked. Yes, sir. Can you go ahead and put them in that thing? Yeah. So we'll get your sound back to normal soon. 31, 9, 8, and 5. So now with this answer, thank you for bringing me back. I got attention span that can be measured in very small pieces. As far as correct answers, there were only 5 people total that, well, it could have been the same person, could have been only 3 people total, that selected A or B. All right, so that's back on. So now they should have me on the normal sound. Go back and mute this so that we don't have sound problems. Turn this back on. Hopefully everything is back to normal. Excellent. Yeah. Change this to their classroom. So you guys hear me now in the normal way? Yes. Okay, good. Sorry about that interruption. It's got to be that I left the thing on or something overnight, or maybe the power outage. Okay, so looking at this here, we couldn't have 1 or 2 as the correct answer because this is good out to the units digit, and this one is good out to the 100th digit. When you're adding numbers, it's the greatest of the least significant digits is the greatest significant digit of your answer. And, like on the test, when you're putting your concept, if it has addition, you should put something to that effect. And when I say it never sounds good to me, but it always feels good when I write it out with the numbers above each other in columns. Then I can say, okay, where is the least significant digit in each answer? The least significant digit is the farthest to the right digit that's significant. So in the first number, that's its least significant digit. And you can always, with an ambiguous number, you can put a bar across the least significant digit, and that tells you which one's the least significant digit. This one here, if it's not exact, then it has the units as the least significant digit. So if the 601 is not exact, I look at those and I say, well, I have hundredths versus units. Which is bigger between hundredths and units? Units. Hence, my answer is going to be good to the units. So I just put a dashed line here, add it up, and my answer is going to be everything that's on the left of that divider between significant and insignificant. So my answer is 1240, which has 4 significant digits.
It'd be 1140.
11 is 11. You're right. I carried a 1 that isn't there. Man, I could have just looked up here where it was added correctly, but no, that wouldn't be like me. So 4 would have been the correct answer unless the 601 was exact. And I told you to assume that the other one was not exact. If the 601 was exact, then those digits would have been significant as well, and you would have had 6. So 3 could not have been the correct answer. Why do you suppose the biggest answer we got was 3 that could not be the correct answer?
Use the theory behind the significant figures rule for multiplication division.
Right, because people use the rule for multiplication division for an addition subtraction problem. You have to make sure you use the right rule for the situation. And of course, the second most common answer was 5, which is again people using the multiplication rule, assuming an infinite number for 601 and then 5 for the other. So remember, addition has a different rule than multiplication. Okay, now I really got to go fast. I've done more than half of my time. And yeah, well, we're starting chapter 2. Chapter 2, we started doing some physicsy things instead of just numbers and mathy things. So we had vectors versus scalars. Make sure you know the difference in a vector and a scalar. Vectors, of course, have direction along with magnitude, magnitude being the size. Should have units for everything that has units. You know, some things don't have units, but most things have units like, 1 mile, 3 years old. So make sure you have units if units are appropriate. The difference in displacement, time, velocity, speed, acceleration. Make sure you know your definitions of what speed is, what acceleration is, and that you don't get the two confused. We had the kinematic equations. You'll be given the kinematic equations. You've already seen the equation sheet, except for I need to add on to that the quadratic information. So make sure you know, hey, this is this formula, this is this formula. So that when you get a problem that's going to use kinematic equations, like you're going to have virtually all your problems, you know how to use them. And if it's a kinematic problem, right now for physics, we always have to have an explanation of the concept. And so your explanation will be, well, this is a kinematic problem. I'm going to choose this kinematic equation because, give your reason, and go for it. Right? There's not a lot to think about. As soon as we get into chapter 4 and we start talking about dynamics, the forces and why, there's a lot more in the concept that's going to need to be there. And once again, okay. That was my slides? Okay, can you change like you did last time? I'm sure that my Wi-Fi went out again. I will contact IS to find out why my Wi-Fi keeps failing. I had at least one student that said that she preferred it this way, although I know that the focus is not great on the screen. So picking back up, we need to be able to solve these problems. And so I'm going to have 2 questions here on problem solving. The first one, a very important thing, but a simple one to do. For a 2-dimensional coordinate system, what spatial relationship must the x and y directions have? When you have a problem on the test that has directions in it, which would be everything from chapter 2 and 3, make sure you draw something to indicate what direction you are considering x what direction you are considering y. Don't just say the x direction and the y direction, because the person who's reading your solution might have made a different assumption for the x and y directions. You need to be clear on what you have chosen there. So let's go ahead. By the way, how many people went and watched the volleyball match Saturday night?
I didn't work it.
Yes, I saw Paris there. Paris was one of the linesmen. We had two of our classmates from Southwestern who were playing in the game. It was a well-fought battle that was very close in the fifth and final game. So it was fun times. Okay, everybody said they must be perpendicular. That's correct. They have to be perpendicular because you need to have your two directions independent of each other. So motion in one direction doesn't change the position on the other axis. Okay, the steps for solving kinematic problems. I'm not going to actually read these. We all have reading skills all on our own. But make sure that you are comfortable with, I've got to stop the polling I left open for some reason. So it was covering everybody at Southwestern. I couldn't see them. Make sure you're comfortable with these steps. You remember how to go through solving. Remember to draw figures. If you don't have to draw a figure on a test question, it will say so. So if it doesn't say you don't need a figure, think about, okay, what figure is going to help me understand this problem? That's the purpose of the figure, to help you understand it. And make sure you have an appropriate figure to help you solve the problem. Okay, so like I said, I'm going to leave the reading to other people and go to solving a problem. Now, you had homework problems that were due on Friday that were this kind of thing, except for they were two-dimensional. So we start with the one-dimensional problem. You want to throw a ball straight up into the air. It reaches a height of 3.3 meters above the ground. If it leaves your hand at 1.2 meters above the ground, how fast do you throw it? First thing I do is draw a picture. Picture is drawn here except for one thing. It doesn't show that the ball continues down to hitting the ground. And the problem does have the ball coming down to hitting the ground. So after having the figure drawn, the next thing I do is I put my variables. So this is one-dimensional. I specify that's my y direction. Up is my y direction. I throw it from an initial height of 1.2 meters above the ground, so I'm just going to put the ground as my reference and say I'm starting at 1.2 meters. Y final is 0 meters. V y initial is unknown. AY is equal to minus 9.80 meters per second squared. The minus sign because the acceleration is downward, and I defined up as the positive direction. The first question is, how fast do I need to throw it? The second one, how long is it in the air? So if I'm going to answer this in the order given, which I'm going to, the first thing I'm going to do is say, okay, I want to find the speed necessary to get to a height of 3.3 meters. I didn't put that in my knowns because I went to the end. Because you know what I do? I assume problems where I shouldn't. So I'm going to add in here y, and I'm going to put b just, that's not a y, it turns out. And that's 3.3 meters above the floor. Make sure you have the same reference point for all your heights. What else do I know is going on at the top? Velocity is 0. So I'm going to put, now I say velocity, I should be very clear, the vertical component of the velocity. If it's a two-dimensional problem, the horizontal velocity is not going to be 0, it's just the vertical. So VYB is 0. So there's two additional variables. And now for part A, where I've conveniently used B for my subscripts, that was silly of me, I will now use those red things and not this one here. So my YB is 3.3 meters, my Y initial is 1.2, my VY final is 0, and what am I looking for? VY initial. And I know the acceleration. There is a variable that I haven't named time. I don't have time, and I don't care about time for part A. So I'm going to use the kinematic equation that doesn't have time. You'll have your list of equations, and you'll say, oh, there it is, the wonderful equation of y final. Now, it will say x, but I'm using y, so I just change x to y. So I just need to solve that for Vy initial. I will immediately put in my 0 for Vy at the top. And, right, that just makes my math easier. Multiply both sides by 2ay. So that those cancel. And I'm left with minus Vy initial squared equals 2ay y final minus y initial. Put the minus sign across, square root. Question, Jordan.
At what point are you supposed to write your explanation?
In our case, I've been saying things all the way through. When I do them in class, I never write down the explanation because I'm yammering. In your solution, I always put my explanation right at the top. This is what I'm going to do. Then I do it. Mahala.
If it's a one-dimensional problem, then do you have to include in the subscript the y-axis?
No, you don't. I did, to be clear. The question was, if it's one-dimensional, do I need to include a subscript of y? No, if it's one-dimensional, you can just use one variable. No, not worried about it.
And if it's two-dimensional, is that
If it's two-dimensional, you have to have something to distinguish the two directions. I mean, you could use some other set of subscripts. It's up to you. But if you use all subscript x's to mean x, it keeps it clear. Okay, so now move that sign across, and I'm ready to solve. So I'll have Vy0, that's a y, trust me, is equal to the square root of minus 2ay y final minus y initial minus 2 times minus 9.80 meters per second squared times 3.3 meters minus 1.2 meters. 3.3 minus 1.2, that's 2.1. 2.1 times 2 is 4.2. 4.2 times 9.8, I don't know, somewhere around 43-ish, square root of that. I don't know. So Steve's pulling out the old calculator to give us a number here.
$41.16.
43, 41.16, not close.
Square root is 6.41561.
6 point what?
415 or 416.
Okay. 6.416. How many significant digits do I have? 2. Now I put out 4 digits here, 2 more than I have for significant. So if I'm writing my answer will be, plus or minus. Should I throw it up or down? I could swear I heard somebody say, throw it down. To get up to 3.3, I'm going to have to throw it up. So it'd be positive, so I'd have the answer there, 6.4 meters per second. Now for the next part, how long does it take to hit the ground? You have a question, Paris?
Would it be okay if we put, let's say, 4 digits like that, but we put a bar over the 4?
Yes. Yes, if you put 4 digits and put a bar over the 4, that tells me he knows it's only good to this digit. That's perfect. Part B, how long does it take to hit the ground? How would you solve this?
You know the variable except time, so you can use any.
Okay, you know every variable except time, so you could use any. One person started saying, well, you could use the quadratic. You could, but now that we know the initial speed, let's make life easier. Because we know the initial speed and actually, wait a minute, I was thinking the wrong thing. I was thinking we knew the final, well, we could calculate the final speed and then we could calculate the time without using the quadratic. That's where my brain was going. So I'm going to do it without using the quadratic just because it's easier math. So for part B, I'm going to start with Vy final squared minus Vy initial squared all over 2ay. But now I'm doing this going to the ground. So I'm going to the ground, the y0 is going to be 0, and the Vy final I'm going to find. Why am I doing this? Because it's just not going to require me to use the quadratic. Question, Jordan.
The y0, y initial wouldn't that be 1.2?
I crossed out the wrong one. You're correct. I hate it when I make mistakes, but I really hate it when we get to the end of the problem. If we got to the end of the problem, we would have realized, we've got a square root of a negative number. There's a problem there. So thank you. So solving this for Vy final, I have to multiply everything by 2ay. And then I have to add Vy initial squared, have that whole thing square rooted. And given that I only have 9 minutes, I'm actually not going to wait for you to get an answer because got to hurry up. But we would find the speed here. We have two answers. It's still plus or minus. When it hits the ground, is it going to be going up or down? Down. So you can use your intellect to know that it's going to be the negative value. And once you find that, then you can say Vy final is equal to Vy initial plus AYT and solve that for time. And so that's a way of doing the same calculation in 2 steps, but without having to use the quadratic. So it depends on what you're comfortable with, which way you're going to do it. Okay, now to the final chapter, chapter 3. What's different between 2 and 3 is that we're adding another dimension. So we're doing problems in 2 dimensions, basically vertically and horizontally. And remember from our demonstration, those 2 behave independently. You can solve the vertical problem separately from the horizontal. That's what you did for your homework on Friday. We had the addition of vectors. You're going to have a vector addition problem. You're going to need to measure your vectors' lengths so that you have a scale that's consistent and the angles for your vectors to show them adding tip to tail. So you need to make sure you can show how vectors add tip to tail. You need to be able to take a vector and break it into its components, its horizontal component, its vertical component, and then work the horizontal problem separately. Okay, horizontal problem separately from the vertical problem. So here's the steps for an analytical vector addition. Why did I not show the steps for graphical? Because the steps for graphical, I just said. Make sure you have a scale. Make sure you actually measure them. Do the tip to tail. If you're doing an analytical, that means you're actually doing numbers. Then you use your trigonometric functions to break a vector down. Let's just take an example. Let's say I have a vector that is 6.4 meters long at an angle of 30 degrees. East of north. So that's I want to break it up into the components. Components, their name means, they're the pieces that make it up. One's going to be parallel to my x-axis. So I've defined an x and a y-axis, x parallel to east, y parallel to north. And so starting at the end, my x component and y component have to add to give me my total vector. So I have there in blue the x and y components. The x is the horizontal one, the y is the vertical. So here's a x, here's a y. If I want to find ax, I'm going to use my trigonometric functions. Ax is the opposite side of my given angle. I know the hypotenuse, and so the trigonometric relation that relates Opposite and hypotenuse is sine. And so I would have sine of 30 degrees equals AX divided by 6.4 meters. Solve that for AX, you just multiply both sides by 6.4 meters. Now I chose my angle because it's easy. Sine of 30 degrees is 1/2. And so that's going to be 3.2 meters. So that's how I got the x component. Y component, which trigonometric function will relate a y with the hypotenuse? Cosine. And so I would have, following the analog, okay, cosine 30 degrees is 0.866, but I actually can't multiply 0.866 by 6.4 and get anywhere close to the right answer in my head. But that's how you get the components. You break your vectors up into components. When you're adding, you add like components. That means you add the x components together to get your resultant's x value. You add the y components together to get the resultant's y value. Okay, and this is the last slide. Woohoo, 4 minutes to go. We got there. A problem with the golfer hitting a golf ball. In this case, he's hitting it from the same elevation as it lands. Now, if it's the same elevation that it lands, you'll find a range equation commonly in textbooks because it's a common problem. If it starts from a different height than it lands, that range equation is not going to be the one you use. So I always do these from the beginning. So how do I do it from the beginning? I break things into components. I put my horizontal and my vertical. And I will have my x initial equals 0. X will go in that direction, y in that direction. X final is equal to what I'm looking for. Vx initial is equal to, and it says for a given speed v, so I'll just have to put v cosine of 54 degrees. Now notice, here, my x component, I use cosine of 54 degrees. Here, I use for my x component sine of the angle. Why did I shift from sine to cosine? It's from where the angle is defined. So you have to pay attention to where your angle is from. Oftentimes, people slip into the trap of always saying, oh, the x component is going to be the magnitude times cosine of the angle. That's the case if the angle is between the x-axis and your vector, which the vast majority of the time is true, but it's not always true, so you have to pay attention. AX, the acceleration in the horizontal direction, what should that be? 0. And then the time, I don't know. Y direction, y initial 0, y final 0. Vy initial equals v sine of 54 degrees. AY is equal to minus 9.80 meters per second squared. And again, time I don't know. So I look at these. My v is unknown. My time is unknown. And my x final is unknown. It seems rather undoable. You can solve it, it says, in terms of the speed. So we're going to treat v as if it's something we know, even though we don't, and get a function of v. So if you're not considering v an unknown, then that means on the right-hand side, you only have one unknown, the time. So I would take the right-hand side and solve that to find how much time it's going to be in the air. In this case, it's actually going to be easy. Let's just put the equation with everything. There's the equation with everything. But the y final, y initial are both zeros. And so this comes out to be I forgot a 1/2. Trying to hurry. Solve that for time. Notice that there's zeros, time, and time squared. So I can cancel one of the times. And I will end up with time is equal to 2vy0 minus sine. So I get that equation for the time. Once I have the equation for the time, I go over to the horizontal and plug it into my range equation, which would be x final equals x initial plus vx initial t plus 1/2 ax t squared. And I solve to get an equation for x final as a function of v and the time. Okay, actually not in the time because the time I substitute. We're out of time. I'll see you in lab tomorrow for the exam. Make sure you don't have a cell phone with you at your seat. Make sure you remember to write explanations. Look at the samples on Moodle to see my examples of how I write the explanations if you have questions about that.